In college algebra, we wrapped up our factoring notes. On Tuesday, we made it through number 5. So we're going to start on number 6. Number 6 is a very basic, straightforward problem. You're just looking for two numbers that multiply to negative 18, but add to 3. That 8 looks kind of sloppy. There we go. So we want 6 and negative 3. Both of those conditions check out, and you're done. On a problem like this, without a number in front of x squared, see right here? That's all you have to do. This is a very simple problem. You only have to check two things, and you're done. Now, number 7, that one ranks as a harder problem. Some people think it's easy, but I think it's a harder problem. So first off, you got this weird y squared over here. So one way to deal with that, and you can just memorize this, is in your answer, you're going to have an x for that x squared, and likewise you're going to have a y for the y squared. If you're wondering why you're going to need that, well, when you FOIL this thing out, for the last, you're going to go y times y, and you get y squared. To get that xy in the middle, that's the inner and the outer. So if I FOIL this out, I'm going to get xy and xy, and they add up to this. So if that makes sense, then cool. If you just need to memorize that you need to write y's on the end because of the y squared, then go that route. The next hard part is the front number. Because of this front number, that makes this a little harder. So what you need to do is multiply first times last. We go 2 times 3. And that's what we need our two numbers to multiply to. And we need them to add up to negative 7. So hopefully you see it's negative 6 and negative 1. But that's just the beginning. One way to do this is to put those in fractions. It's this clever trick with fractions. And you write the front number under them. So the front number is the 2 over here. And reduce. So negative 6 over 2 reduces to this. Negative 1/2 is already reduced. So one factor is negative, or sorry, I messed that up. One factor, the bottom number gets the x, is x minus 3. And the other factor is 2x minus 1. Or in this case, we have the y's, so throw the y's on there. So 2x minus 1y, or just minus y, and x minus 3y. And that's it. If you like the box method better, then make a box. That's an ugly box. Let me try again. And you write the first term in the first spot, last term in the last spot, and the two numbers you found appear in the two remaining spots. So now I need to figure out what I would multiply around the box to get the inside. Definitely x and x. 2 times 1 will give me 2, but I can't put the 2 here. I need to put the 2 here, so I can go 2 times negative 3 and get negative 6. It's a puzzle that has to, like all the pieces have to fit. And then 1 times -1 gives me -1. And it works out. And that's the same thing we got a second ago. So pick the method that you like best. As long as you end up here, you're good. Next is difference of two squares, and this means you need to be subtracting two terms, and they need to be perfect squares. So if you have two terms, they're being subtracted, and you can square root them, then it's this really easy scenario. All you do is you create your two parentheses, square root the two things. You got to write it twice. And you add and you subtract. And that is all you do. So they got to be perfect squares, where if you square root it, you get a whole number. And they have to be subtracted. So same over here with number 9. Maybe hit pause and try it without me. Can't do that last parenthesis. There we go. So square root is 9x and 7. Make 1 a plus, 1 a minus. And you're done. Number 10 is almost just as easy. There's just one catch to it. So you can square root those two things. Square root of x to the 4th is x squared. That's kind of weird. Square root of 81 is 9. Make 1 a plus, 1 a minus. And many people accidentally stop right there. But always ask, can you take it further? And when I see those x squareds, I'm wondering, can I take it further? I see a plus right here. We're stuck. Can't do anything with that. But look at this one. Isn't that another difference of two squares? Copy the first thing. Can't factor that anymore. And then you create two parentheses for that next difference of two squares. And you got x plus 3, x minus 3. All right, I hope that one made sense. It's kind of a trick question because there's two parts to it. All right, moving on, some harder stuff. So there is a chance that you'll be asked to factor two cubes, and you have two scenarios. They're either being added or they're being subtracted. It's also confusing because A, for example, this A right here is not 125. A is the cube root of what's typed. So, oh, and by the way, I forgot a parenthesis up here. So when we start with number 11, we need to cube root these two things. So when I cube root x to the 3rd, I get x, and x is A. Those are just formulas up there. We're going to plug into those formulas. The cube root of 1, that one's easy. That's just 1. That's B. And we need to plug those two numbers into that formula right there. So since I'm adding these two cubes, I'm going to add A and B. The next, this trinomial you see written over here is the tricky part. You need to square the two, so x squared and 1 squared. Let me write a better 2. And then you need to multiply the two things, A and B, and subtract. So x times 1 is x, and you subtract it. So all this is up here is a formula. You just need to plug into it. You need to trust it, It's very weird because if you're adding the two cubes, you subtract over there in the trinomial. And if you're subtracting two cubes, you add in the trinomial. Kind of weird. So let's try the difference of two cubes. First off, cube root both of them. And you get 5x, which is A, and 2, which is B. Then you plug into this formula, and you got it. So a good step would be to plug in with parentheses on this one. First off, we're going to go 5x minus 2. That's pretty basic right there. But the trinomial is hard. We're going to go a squared. So I'm going to use parentheses. And we want to square the b, so that means plus 2 squared. And for that middle term, I need to multiply 5x times 2 and add. And then simplify. So final answer, 5x minus 2, 25x squared plus 10x plus 4. All right, hopefully the cubes made sense. Number 13 is very basic. It looks a little ugly at first, but don't forget to take out a GCF. So if you take out a GCF, hopefully you see it's 2x. You have a nice leftover expression. And most people are fine factoring that. You need two numbers that multiply to 4, but they add to 4. So x plus 2, x plus 2. Please don't stop there, though. What about this? That gets tagged on there as well. All right, that's as far as we went. See y'all later. Bye.